So yeah, the project I'm going to talk about is our Deep Energy Retrofit at 4 Beechwood Crescent. The owners, Andrew and Marie, are here as well, so if you want to get the sort of owners' experience, you can talk to them. But I'd just like to thank them for giving us the opportunity to work on such an exciting project. We're definitely learning a lot, and the project sort of is really very exciting. All right, so I'm just going to talk about it kind of like chronologically and ground up, sort of just go through the different features of the build. It started with in the design and planning phase. We had a charrette with architects, Ed and others from the high performance building community, and Sustainable Edge, the mechanical engineer. And so this is an early rendering of the project, and this is sort of where we were a couple of months ago. The site is a challenge for retrofit is you're dealing with an existing site and an existing building, and so it was quite favorable for solar access. It has this is sort of south-facing on the street, so you don't have a lot of shading except for the tree, which only shades in the summer. And then the sort of shape of the house, the glazing, the overhangs are optimized for solar performance. And then there's going to be a solar array on the roof, which is an integral part of the mechanical system, hybrid PV and solar thermal. So just the background on the project, a typical East York post-war bungalow, small by today's standards, for a family of 4, and then also very little insulation, quite leaky, and so the goal was to create more space and create a near passive house building, and that being a retrofit with the existing masonry was challenging for air sealing and also getting a continuous blanket of insulation around the whole house. So this is sort of first step demolition of everything, and then like many renovation projects, you always have these surprises that you weren't anticipating, and so the existing footings, the existing footings were fine, but the walls weren't built in the center of the footing, so they required underpinning. So that was sort of, once we had reached this stage, we found out we needed to underpin. But I think that in the end, with what we were trying to achieve, that I think turned out for the best, because that allowed us to insulate beneath the slab, and also the opportunity, if you have to underpin anyway, to go down and get more height in the basement. And so really, I think in the end, that kind of worked out to the benefit of the project. So this is just underpinning in progress. And then, once we got beyond this point, it's kind of moving forward again with building and going up. All right. And so while this isn't a certified passive house, we're definitely building with the passive house principles in mind. So we have high levels of insulation, high levels of air tightness, mechanical ventilation with heat recovery, optimized solar design, and thermal bridge-free construction. And so, back to the planning phase, in order to detail the air barrier and the insulation layer, it starts on paper, because it's easier to work all these things out on paper before actually going and trying to build it. And so we had a lot of different conditions with the existing building and the new second story. So all these things were carefully thought out, all our transitions to ensure continuous air tightness. So high levels of insulation. The goal was R2000 levels of air tightness, which I'm happy to say we beat substantially. I think our latest test from Sherman and Greg was 0.44 air changes an hour, so that's better than passive house new build, and this is a retrofit. So just starting from the ground up, again, the need to underpin gave us this opportunity, access to the subsoil beneath the slab, and so we buried a shallow geothermal loop, which will act as a heat source and sink for the heating, cooling, and domestic hot water of the house. And this is going to be coupled with the solar thermal array And then here's our sub-slab air barrier, 10 mil poly. Again, we took very careful in our detailing. All the transitions are taped with a flexible, very adhesive tape, the 3M flashing tape. And then even things like the perimeter insulation on the slab, each of those penetrations is through a patch of blue skin, so it seals the fastener hole. And then here's a shot just before we're ready to pour. You can see the in-floor tubing for radiant, 4 inches of XPS under the slab. And here's our 10 mil air barrier taped onto the interior weeping tile, which was again another benefit of underpinning the opportunity to waterproof inside as opposed to excavating the exterior. And then up here you see this gold coating, which is in progress, and that's a liquid fluid applied air barrier product to seal the existing masonry walls. And just a couple of other details here. We dug our plumbing as low as possible, so all the penetrations were sort of coming straight through the slab as opposed to having a horizontal pipe cutting all the way through the insulation. Again, easier to seal, and then you get all the insulation that you can underneath. Same thing with the new structural steel. We installed the footings deep enough so that we could cover them with a blanket of insulation. I looked into high compressive strength XPS to go under the footing, but you have to buy that in lift quantities, so we weren't able to do it. If we all get together, we can buy a lift of this stuff and use it on our next project. Yeah. All right. So this is just a sort of detail on one of the most challenging in terms of air sealing features of our retrofit, the existing floor joists that sit in the masonry wall, huge gaps, very leaky, typically the most leaky areas in any existing house. So the large gaps are filled with mortar, and then we use this stow system. So this is the stow gold fill with mesh, so it's flexible, but it also seals all the cracks, and then you paint over it with the stow gold coat. But then this is just a sort of the level of detail that we had to go through to achieve this air tightness and also the sequencing. So we've removed all the perimeter blocking and floor sheeting. And you can see we just did this band so in advance of putting the new subfloor, because that would make it more inaccessible after the new subfloor is down. And then moving up again, the top of the existing masonry wall got this is an earlier drawing, but this continuous layer of exterior insulation, and then on the inside we're using polyurethane spray foam, 2-pound foam on the stud cavities. And we had to transition the air barrier from the interior to the exterior where we taped the sheeting. And again, so that was sort of the planning phase, and then here's in progress our air barrier transition from the existing masonry wall. On the new construction, the second floor, it's going to be on the exterior of the building, so we have a membrane, self-sealing membrane, blue skin between 2 plates, and then that makes sure the transition is airtight. So here's sort of the inside. You see the stow gold coat and the transition membrane there. And then here we are framing the second floor. Similar to Ed's, only the insulation, I guess, is more petrochemical based. 2x4 structural wall with this 4 inches of exterior foam. So in terms of thermal bridge-free construction, I think this is a very good way to go. There's absolutely no framing members that span the structural wall with the exterior sheeting there. And then one thing we looked at, we had a wall section from the sustainability consultant, but we reviewed it for constructability. The way it was drawn made it hard to, or impossible to build it on the ground and stand it up. And so then the extra labor of adding all this insulation after the walls are up is quite significant. So we modified the details so that we could build it on the ground and stand it up. Then all this insulation gets applied, on the deck, which is a great savings in labor, all the openings can be cut accurately, and then we stand the wall up. And then the end of this insulation board actually turned up and covered the rim joist. And so yeah, here's some thermal bridge-free construction details. Here's the window opening. Similar to Ed's project, we then installed 3/4 inch plywood buck to hold the window, but there's no framing through this insulation. And here's a corner, so the structural corner is here, but here there's 4 inches of pure foam. And again, taking great care to notched out the foam so that we had a nice tight-fitting corner, pure insulation, no thermal bridges at the corner. And then we always take care with our air sealing and detailing, but this house being the goal to achieve a near passive house, we sort of took the extra steps, and we tried a number of different techniques. This 3M flashing tape is really fantastic. Also, that's a neoprene boot for waterproofing roof penetrations, but you can similarly use it to air seal penetrations in the house, and then for other holes, smaller holes, just sealant. And then in terms of framing details to achieve that thermal bridge-free construction, the house is essentially a very simple geometric shape. It's just a box, and all the eaves and overhangs are applied, and so there are no structural members that will penetrate the insulation layer to frame any of these things. They're all screwed onto the exterior. And so here you sort of see in progress all these eaves and this dormer effect are all created with by applying the features to the outside of the insulation. And then window installation. We got the windows on the project are fiberglass frames with EPS insulation in the cavities, and then triple glazed with argon fill. So here's a 3/4 inch plywood window buck. We use this expanding foam tape, which it continues to expand so that as your building moves and your framing expands and contracts, the foam will always press outwards. So unlike a can of spray foam that cures to a certain size, this will give you continuous positive pressure and keep the air seal. And then we use these used shims. So unlike conventional window installation where you have opposing cedar shims that would penetrate the full depth of the window frame, these ones we notched out of the foam, so you have a continuous insulation and air seal all the way around the window opening. And lastly, we got these strap anchors, and that just allows us to not fasten through the frame, which I like. You have to make a hole in the frame, which needs to be patched afterwards. And then quality control, at least on the air sealing, we own our own blower doors, so we do a progress test. In this case, we had Blue Green come out and do a couple of progress tests as well. So the initial test, I think we had 0.82 air changes, and we did a round of air sealing, and then post drywall, we're down to 0.44. And then, so after we've worked very hard on air sealing and having this continuous layer of insulation, thermal bridge-free construction, then we get into the mechanical system. I don't think Mario's here, but I saw Jennifer. So if you have any questions on the mechanical system, you can ask her, but it's centered around a 2-stage heat pump, and that supplies heating, cooling, and domestic hot water. There's a storage tank for domestic hot water and a storage tank for the hydronic heating, cooling. And then the heat sources and sinks, there's the shallow geothermal ground loop and also the solar thermal array. And then this distribution in the house, we have radiant ceilings on the first and second floor, which provide heating and cooling. And then mechanical ventilation, ERV, with a preheat or preconditioning coil, so it'll preheat or pre-cool the incoming ventilation air depending on what mode the system is in. Yes. All right. A lot of pipes and pumps and valves. All right, and then here's where we are now, getting close to move-in. Andrew and Maria will soon be enjoying their cappuccino house. All right, thank you. I feel like I went really quickly, so I'm just going to add the roofing. Again, sort of sustainable choices. We have standing seam metal roof, highly durable, steel recycled content, plus it's highly recyclable. It's like a 50-plus year roof. Then there's a flat roof section on the rear, which is a white membrane. So both these qualify as cool roofs based on their solar reflective index. And all the downspouts are coming to this corner, and there's going to be a rainwater cistern in the house. We have separately plumbed supply lines for non-potable uses, the toilets, cold feed on the laundry, and exterior hose bibs. All right, now thank you.